you'll notice there's tons of different options for boxes, but why are there so many different kinds? So in front of me, I have a whole bunch of different things. When you start getting into electrical and you start apprenticing, or you're at home doing your DIY thing, you'll notice there's tons of different options for boxes. These are all residential style boxes, although some of them, I guess, could be used for commercial depending on your jurisdiction and the application. But typically we're doing this in wood studs with Romex or 12-2, 14-2, things like that. But why are there so many different kinds? And what are the options? Some of these you may have never even seen before. So to start out, we have different boxes that we just need, like standard boxes, but we might have a depth issue. So if you look at these three boxes right here, these are three essentially the same box, but if we flip them up on their sides, we'll notice we have different depths. So each one of these is a different depth, meaning we might have a deep device that we have to fit into one of them, or we might have a shallow device that we have to fit into them. So the actual constraints of the environment, there might be something blocking back here, so we couldn't actually get a deep box like this. But if you go too shallow on the box, you might not fit a deep device in it. So to start out, essentially, we just have an environmental thing that we might have to contend with as to why we would want to use one of these or the other. Now this one, I probably should have flipped this up. This is a super deep box. All of these are by ABB. They're the Carlon series of boxes. So Carlon sent me a couple of different options, and we'll talk about them as we go. But look how deep this is. This is their newest option. This is a 24.5 cubic inch box. So that just means that what we can fit in this, we can fit more things. We'll get into code here in a second and what code says about all these different boxes. But these are essentially single gang nail-on boxes because we nail them into a stud. This one does have a couple more mounting options. It actually has a plate as well as these. So if you don't want to nail, or if you're in like a really tight space and you can't get your hammer in there to nail, it has these screwing options as well. So you can just bend this and break this tab off if you wanted to. If you had a really small space, or say you were in a drywall environment and you didn't have a cut-in or pop-in box that we'll get into here in a second, you could break this off, take these out and slide this back in there, and then you can actually screw through the inside of the box because the manufacturer designed screw holes so that the head of the screw sits flush and it's not going to nick anything or short anything out by hitting the terminals on the inside. So those are essentially the new construction options. Now there's old work boxes as well, and that just means we're in like a remodel environment. We might have drywall already up. This is if you're in like brand new only studs, there's nothing in your way. But if you have drywall to contend with and you're just trying to cut a receptacle in, you don't necessarily need to be against a piece of wood. You just need to find a place on the wall where you've got an open chase somewhere between two studs, and you cut a rectangle hole, and then this thing would fit inside of it. So this is a pop-in box. Some people call it a cut-in box. There are shallow options and deep options for these as well. But you notice these got these handy little flaps on them. So these flaps actually, when we slide this box in and we start screwing these screws, it pops these flaps up, and the flaps start to tighten and tighten onto the drywall, and it cinches it in place and holds it in place so it doesn't go anywhere. So we will use cut-in or pop-in boxes all over the place. They have this single gang option, which all of these are. This is a 2-gang, 3-gang, and 4-gang style box, and we will get into that here in a second. Something like this. This is what we call a low voltage ring, low volt ring. There are nail-on styles of these as well as pop-ins, but the same thing goes here. We don't actually need the back of a box because we're probably dealing with low voltage where the codes don't regulate that we have to have all of our terminations inside of a box. We might have speaker wire, or we might have like a doorbell or something like that. So we just need to be able to reach our hand in, grab the wires. We don't actually need to be inside of a box. Then we have some weird specialty boxes. All of these are kind of specialty that we would use for really weird situations. This type of box just has a mounting on the top. So if we had a stud right here and we needed to secure it to the stud, we could do that. We could do it on the top, or we could do it on the bottom. So if you had something like this, you could mount it from the bottom. This becomes really useful in some step lights or things where we have very specific places that we have to put something, but we might not have a vertical mounting option. So being able to do this horizontally is super helpful. The other thing about this is it's adjustable. So this arm will actually move backwards and forwards, which pushes the entire box out or back. So depending on what kind of material that we have, that might be another reason why we select a different box. If I'm going in stucco, you know, stucco could be 1/2 inch, could be 1 inch. It just depends on what kind of material. There might be some kind of thick wood or tile, stone, or something like that. So I want to make sure that I have the ability to adjust this box and bring it forward depending on what thickness they decide to put over the top and cut out of this. If this thing's too far back, you'll actually have like a gap on the inside where there's no box at all. So you just need to be able to adjust it and scoot the whole box forward so that the plate will sit flush on the wall. This is another style of essentially the same thing. It just gives you the horizontal option. So you can stick this on a stud. It's got these sharp bits on it, so you can actually hook it onto the stud and then yank it in place, and it holds really, really well. And then you can throw a couple of screws in it just to make sure that it's really solid in there. They're both the same depth, but you can see, you know, like there's a huge variance in the depths of these boxes, and the depth becomes really important once we start talking about the volume per code. The next kind of specialty boxes that we have, these are really cool actually. I use these things a lot. Sometimes you need a really shallow box, and there are boxes that are literally just shaped like this. There is no extra side on them. They're usually 8 cubic inches. So if each one of your number 12s is worth 2.25 cubic inches, you could see that using 2 pieces of 12-2, you got a black that's 2.25, a white that's 2.25, and you got like another black that's coming, you know, one coming in, one going out, that's 2.5, and another white that's 2.25. So we've already got 9 cubic inches, and that doesn't even count the grounds that are in there, and there's 2 grounds, but you only have to count one of them. So you can very quickly see, like, a box like that, you can only put 1 wire in. You can't have a wire in and wire out for code. But it does allow you a slim profile. So with this option, it gives you this extra junction box over here, all this extra space. So this, where it normally would be a 8 cubic inch box, is actually an 18 cubic inch box. So in something like this, you could have conductors coming in and leaving, and you can have a device in there. But it is a slim profile version of this. So here in my studio, I've used several of these. Y'all can't see, but on the wall next to me, I actually have a concrete wall. Like, this is a sub-level, like it's built on a hill. So like they dug this part of the building in. So there's a concrete wall right there. But I didn't stack my studs like normal studs sideways. I twisted them on their side and then mounted them like this, so I could save as much space as possible and still mount every single one of the studs all the way to that drywall. So I had like a really firm hold. But that also means that I can't put a deep box in there because I've only got the width of one stud. So I actually used a whole bunch of these, and that's how the receptacles on that wall fit. I couldn't do this or else they'd be sticking out of the wall. They also do have the same kind of option that's a little bit bigger, so you can pull these open. And it gives you the depth, like a whole bunch of extra depth. Plus it gives you a bunch of different width, but once the drywall's on, this is all you see. So that's pretty cool. You have a little bit of options too. If you wanted it, they give you a little bit of depth here. So, you know, you could probably have like 3/4 or 1 inch drywall and still get away with it. Like if you had double layered drywall, if you're going for a fire rating in a specific like multifamily dwelling or something like that, this might be a really good solution. It just gives you more volume than this kind of a box would give you. So the volume on this one is 30 cubic inches. So that's a lot for a single gang box. That's more than all of these. But there's a very specific use to when you would want to use these. Then lastly, we have the multi-gang boxes. So multi-gang just means that we're going to be using multiple devices. So you might have like 2 switches. This is actually a lighting control cassetta switch. And you might have like a regular switch. So we'll put 2 of those in there. Or sometimes we'll have 2 different receptacles, and we want to put 2 receptacles. We call that a quad out in the field. So if we have a quad receptacle, we have 1, 2, 3, 4, quad, quadruple. We can do that. That is a 2-gang box. And on this style, as well as this style, they give you multiple different options. I think this is really awesome. These 2 are probably my favorite 2 boxes out of all of them, just because they give you an insane amount of depth. Like both of these will fit on a 2x4. It'll back up all the way to the drywall right behind it, because the 2x4 is 3.5 inches. So you can mount this and it goes all the way back and it touches the drywall in the back. So it gives you the maximum amount of depth possible. Plus it gives you mounting options on the side. This one gives you nails, so it gives you 3 different mounting options, because on the inside, on this side, and on the nails, you have multiple different mounting options. And I love that I can just cut this off and still use it in old work environments if I'm in a remodel, and then just screw through the sides. So really versatile. This one gives you 48 cubic inches, so like that's an insane amount. I think this one's only like 49 cubic inches, and it's a 3 gang. So this 2 gang actually has the same volume as this 3 gang. It's just much deeper, and that's where it gets its volume. So really super handy to have. And then we've got a 3 gang, so we could put 3 switches in it, or a 4 gang, so we could put 4 switches in it. This 3 gang has an adjustable thing again, so this can go forward and backwards, and you can mount it from the side. And then this 4 gang is really awesome because it has this flange on the side, so you could frame this in. The problem with 4 gangs a lot of time is once you mount them over here, they're held really strongly on this side. So you could push the box and it's not going to go anywhere. But on this side, a lot of people just leave it loose, so you can push that and it'll wobble inside of there. So a lot of times they sit crooked, they'll push out on one side or push in, because studs are not always perfect. You know, you might have a stud that's kind of kicked or has like a slight bow in it or something like that, so the box won't sit really flush. So you can scab out on this side and put a 2x4 on this side and actually mount to that and have that in there, and then this thing is in really, really solidly. So I like all of those options. So that's essentially it. You can see some of the depth things. What I think is really cool about these 2 boxes that I was just talking about is here we have one that's cut in half. So you can kind of see the depth, right? If we're just putting a regular single gang switch in there, you have so much depth to work with. There's nothing you can't do with that. Now, if you had something that was shallow like this, I don't have this one cut open, but you only have about this much space in there. So you can see the benefit of having deep boxes. But something like this, if we've got a GFCI that's also USB, these things are some of the thickest or like deepest devices that you're gonna run across. This is a normal USB receptacle. It doesn't have the GFCI in it, but adding the GFCI actually makes this thing even thicker. So this is a normal GFI, this is a normal USB, and this is a GFCI with USB. So it's really, really thick. So any of you guys that do stuff with like Lutron, lighting control systems or anything like that, where you have really huge radio raw 2 dimmers, you're gonna want stuff that's deeper. The more volume that you can get, the better, because not only do you have this huge device that's sticking inside of this thing, let's see what this looks like, but you also have all the wire nuts from all the joints. Or if you're making terminations on this, you're still most likely going to be in like a 2 gang box putting 2 radio raw dimmers in, and you're going to have wire nuts back here and all these other wires. So having the depth of the box, it still fits in the chase on a 2x4, but it gives you the maximum possible depth that you can get. I just really, really love that. So that is the essentials of all the different kinds of boxes. There's definitely more variations. These are just everything that I could get my hands on. But let's talk a little bit about the code and what the volume calculations look like. And I'll go over to the board and actually do a calculation so you can see by code how we're supposed to size boxes and how many conductors and devices we're allowed to put in a box. Because believe it or not, you can't just shove any old thing in a box. There's codes for this stuff. All right, so first let's just talk about code really quick. We're going to be we're in the 2023 code. 314.16 talks about all of our conductor fill. It says number of conductors in outlet, device, and junction boxes and conduit bodies. This is an outlet box or device box. So throughout here, I'm not going to read this whole entire thing to you, but you can go through 314.16 and actually look at how all of these things are sized. It goes through in B, box fill calculations, and it tells you we have to do all of these things when calculating the volume of a box, but depending on what we're putting in that box. And it goes into conductor fill. So each conductor itself has a certain amount of cubic inch volume per conductor. Clamp fill. Some boxes actually have inside of them like little clamps that are added into the box that take up volume. So you're reducing the volume when you have a box like that. So you have to take into account any clamps that are inside of it. If you have any supporting fittings that are supporting the box, but there's a fitting or something on the inside that's supporting and holding that box in place, you have to account for that. If you have any devices, so here's another kind of crazy thing. If you have this device and this device, these are the same size devices as far as code's concerned. That's kind of crazy, right? The volume that this takes up is so much bigger than what this takes up. But in here, it says that you actually, for each yoke or strap, which this is a yoke or a strap, for each one of these like mounting yokes for one or more devices, this is 2 devices on one yoke or one strap, a double volume allowance in accordance with the following table has to be made for each yoke or strap. So it's basically saying that like if this conductor, if we find that this is say like a number 12 conductor and the volume that we have to give is 2.25 cubic inches, that means that we have to have a double volume allowance for this device, but also for this one. So it just means we take 2.25 and multiply it by 2. So and then that's 4.5. So we say that this takes up 4.5 cubic inches of volume, but we also say that this takes 4.5 cubic inches. That seems rather silly to me. Rather than just making the manufacturers take a dimension and then stamp their thing with a volume, that's much more accurate, and it would probably help a lot of us out in our calculations and our box fill. But they don't do it that way. They go off of what the conductor size is. So we have to figure out the wire, we have to figure out the devices, and then the equipment grounding conductor. So inside of 12.2, you're gonna have probably a bare copper wire that we consider our ground, green or bare. But because several of them can be mixed together, we actually are allowed to combine up to 4 of them, and we only have to count that as one conductor. That's what 5 says. And then the last thing, we've got this table over here. So table 314.16b1, it says volume allowance required per conductor. So how we figure out what our volume is for all of these things, we have to know what kind of wire we're running. If we're running 12.2, we're gonna be number 12 wire. So we go down to number 12 and we see we're not looking for cubic centimeters, we're looking for cubic inches. So it shows that a number 12 conductor is worth 2.25 cubic inches. So if we had a number 10, 2.5 cubic inches, number 14, 2 cubic inches. Most of the time, that's what we're going to be dealing with when we're talking about box fill, where there are going to be devices as well. So just know that 2.25 is what we've base everything off of. So now let's actually go to the board and do a calculation so you can see a real world example of where we would use this. All right, so let's talk about how we would actually use all of that code mammer jammer out in the field. So we have a single gang box. Say that we have 3 12.2s that are coming into it, and we're trying to put a receptacle inside of here. And we need to figure out what size box can we get away with, because not every single gang box is going to work for this situation. Once you have 3 12.2s, you need to kind of watch out. So we've got a 12.2 that say we're feeding in from the panel. So our incoming hot and neutral are here. We've got our outgoing hot and neutral that are feeding all the rest of the devices in the circuit. And then we've got this one, which maybe we just like forgot about a receptacle that at the last minute we had to add one. So we put a third one, jumped off this device. And this is where we were like, oh crap, is the box gonna work? Does it have enough volume? Because we used all shallow boxes. So, or 18 cubic inches boxes. So to figure this out, we have to know that the wire size that's being used and the device that's going into it. And so we can figure out our device. We said that we have to take a double volume allowance based off the conductor size. So number 12 is 2.25 cubic inches. So we'd multiply it by 2 because we have to have a double volume allowance. And that gives us a device that has 4.5 cubic inch volume that was going to get subtracted from whatever the volume of this box is. Then we have our 12.2. Well, we have 6 current carrying conductors, black, white, black, white, black, white. Each one of them is 2.25. So we multiply that, we get 13.5 cubic inches. That's just for conductor. Then we have our grounds, and we can have up to 4 of them and combine them to be one conductor. So we only need 1 volume allowance for that, so it's just 2.25. So then we take all 3 of those things. There's no extra clamps, there's no fittings, there's nothing else inside of here. We just add those 3 up. So we have 4.5 plus 13.5 plus 2.25, and we get 20.25 cubic inches. So will our box work? Well, it depends. If we have a shallow box like this, we have 18 cubic inches. So that's less than what we have. We have 20.25 cubic inches of stuff, of things we need to cram into the box. And we only have 18 cubic inches of box. So no, the shallow will not work. If we go up a size to the medium depth or the standard depth, we've got 20.3 cubic inches, 20.25 just barely makes it. So this box would work. So this is why it's so important. We have inspectors that are going to go out and check this stuff depending on your jurisdiction. Some of them don't care about this at all, or they'll just look at something obviously and be like, dude, that's way too much. But, you know, figuring out, like, if you're putting devices and stuff, a lot of people are just going to take their hammer and try to like smash conductors in here, and it ends up messing up the conductors. Or they go to put a device in and there's like a sharp edge from a wire nut or something, and it just digs in because they're cramming stuff in here. The whole box and everything can't dissipate heat very well. There's no extra space inside of it. But B, you're probably damaging things. You're either damaging the device by smashing it in there, so when the next person comes to take it out, it falls apart, or you're going to be nicking up conductors and you're not bending them with enough wire bending space on the inside so that they're just gently put into the box. So just quality install work. You need to figure out what your box volumes are before you start cramming stuff into boxes. And then your inspectors, you might actually have them fail you if you don't do that. And it's code, so you got to do it. So hope you got something out of that. Love you, crazy people. I'll see you in the next one.